example, was the person who actually invented the television tube that we have today, and he did that in the process of working with the exact same type of thing which I'm working with. He had to build the television tube itself is an over unity device.
Is it?
Yeah, it's an offshoot of a dynode and a number of other things. And a dynode basically is where you have in a radio tube a cathode, which is the input side, and you have an anode, which the electrons move from the cathode to the anode. Okay, in the case of the dynode, you have alternate anodes in here, which this thing is bouncing off of. And if you have a certain type of material on these anodes, one electron leaving here and bouncing to this one knocks, say, 50,000 electrons loose, which bounce to the next stage, which knocks 5 million electrons loose, which goes to the next stage, which knocks 50 million electrons loose, and then the anode here collects them, and you have 50 million times the amount of electrons active here that you had here. So you have gained 50 million times what you started out with.
So it's some kind of multiplier.
It's a multiplier, and it was renamed by Farnsworth, called a multipactor. And basically he was using like radio emitting substance here. Mm-hmm. You have this same thing in a light detector in cameras and other things, which open and close the shutter based on the ambient light. Mm-hmm. A small amount of light hits a cathode, which knocks some electrons loose. Mm-hmm. And they start bouncing through the dynode system, and they end up being enough electricity to operate the shutter in your camera. So you have an enormous amount of output compared to the input.
Interesting. Is there anything else you'd like to say about this?
Well, the same thing applies in changing frequencies here. The same amount of electricity inserted at a lower level raised to a higher frequency will disturb more of the electro and the magnetic field, which at that point you capture, and you have a huge gain over what you put in.
Fantastic. Okay, well, so that does fall right into what you're talking about.
So you have not violated any laws of physics, but you have an enormous amount of energy that you did not have to begin with.
What do you call it when you capture this wavelength? Do you have a name for it?
When you capture it?
Yeah, like obviously...
Well, you can temporarily store it in capacitors, batteries, coils, or various other systems temporarily, and then you can convert it to some other system that is useful to the device which you need to power.
So the energy just doesn't tear around wildly?
No, it's not just running all over the place.
Yeah.
Sometimes it gets loose in the form of sparks or spacks or whatever.
Is this over here?
The devices which I have invented, which there are a number of them, they all actually accelerate electrons.
Okay.
They're electron accelerators, and one of the outcomes I might mention of the multipactor thing which Farnsworth had, which is a over-unity device without question, is the magnetron in your microwave oven.
Okay.
So all patents are related to magnetrons, multipactors, dinodes, and all related patents are over-unity patents.
Fantastic.
And there's no way to deny it. If the person has any, even slight degree of intellect, they will know immediately that that's the case.
So this has been sitting in front of us the whole time?
Yeah, it's been here since 1920s and 30s in grand form. Before we go to the other devices, this is a component which shows up on some of the devices.
Okay.
And can you read the reading on it?
Give me just a moment here.
I'll bring it even closer if you want so that you can actually read it. The reason I want you to read it is because calculate the input which the manufacturer specifies.
Okay, go ahead.
and then calculate the output which the manufacturer puts on there for that same amount of voltage, and you'll see immediately that this thing is putting out more energy than it was put into it.
So it's
The manufacturer actually states the input and the output, and it's on the label, and they have tested it, or they would not have put it on there.
So it exists.
Here's an over unity device looking right at you.
Okay.
And there are a lot of them that are that way if you bother to calculate the input and the output.
Great. Okay. What is this?
Okay, this is one of many devices which I have built. I would say one of several hundred.
Uh-huh.
And this is one of the sort of intermediate ones.
Okay.
And technology present here is largely 1800s.
Uh-huh. And well, what is this here?
What is the device?
Yeah, what do you got here?
It's a resonant electrical energy generator.
Well, what does it do?
Basically what I do, I take a low voltage, 12 volts at about 7 amp hours from a battery, and I run it through the device. The first thing I do, in order, the high voltage module here has to run off 120 volts. So since I'm intending to use a 12-volt battery, I have to bring the voltage up so that the high voltage module can run.
Okay.
So this is an inverter here.
Okay. Now this is just a Radio Shack part.
Yeah. It's everything you see here except these. Most anyone could get, and these. Now this and this. Unless you get them from me, you don't get them.
So these are your homemade ones here.
Well, they were special made for me.
What are they? Can you give me an idea?
Well, these are 10,000 volt capacitors.
Wow. And what's the
this is a 9,000 volt high voltage module that is similar to the little one that I showed just a moment ago.
Okay.
And this is from the same people. This is about 6,000 volts, and this is 9,000 volts.
Okay.
This is essentially a solid state device, and so is this.
Okay. So how does it go here?
Where does what go?
Where does it start?
Okay, it comes in here,
Okay.
and comes from a 9-volt battery.
Okay.
There's a cord that's calculated to a certain length because it's a frequency that works with it's a quarter wavelength of this coil here.
Okay.
The physical length of the input from the 12-volt battery. And the reason for that is that it will recharge the battery if it can communicate with the radio frequency magnetic field that's in the area.
I see. So it's just constantly recharging.
Yeah, the magnetic field from what's going on here will recharge the battery faster than it's being discharged.
That's great. Besides that being
How do I know that? If you take a light-emitting diode, electricity can only flow in one direction in a light-emitting diode. Take two of them and reverse them and make a pigtail and put them in the line that comes from the battery to the device, and depending on which one's lighting up, you know which way the electricity is flowing.
Okay.
And when they're both lit up, you're taking out and you're putting in at the same time. And the reason you can do that is that they're different frequencies. Okay, we've got 12 volts coming in. We have a kickback diode here, which prevents a kickback from the inverter to the battery.
Okay.
And we also have on the input where the 12 volt comes in, we have this pigtail set of light emitting diodes, which tell you that you're charging your battery at the same time that you're